This is the Analysis in Chains with Nathan Williams and Neal Kieran.
Welcome to Analysis in Chains. I'm Nathan Williams. Joining me today is Dom Povilauskas. Dom is the CEO and co-founder of NOIA, a programmable internet on the blockchain. Dom, thank you for joining me today.
Hi, Nathan. Thank you for the invitation, and good to meet you guys.
Good to meet you too. So tell me a little bit about the project. What are you working on?
So NOIA stands for Network of Internet Acceleration, and we are enabling the transition from current internet architecture to the next generation of internet powered by blockchain, which we call the programmable internet. We are combining the latest internet protocols like segment routing and IPv6 together with blockchain technology to basically provide a platform to open up the infrastructure, unify it, and enable trading of internet bandwidth on decentralized internet transit exchange, the DIDEX. So this model might sound a bit technical. What we do is we connect different networks on the public internet into one unified programmable internet. And we're doing this by using blockchain together with the latest internet routing protocols.
So as I understand it then, is it that there's problems trading internet bandwidth right now? What are the bottlenecks that you're solving?
So I think let's start with the core problem because internet, the way it's designed, it has a lot of flaws. When internet started, it started from just two universities connecting two computers with cable to exchange information. Then more networks connected, ISPs started making commercial internet, and this is how the internet grew, when more and more different networks connected with each other. So internet wasn't designed, it wasn't coordinated, it just happened when these networks connected with each other. And these networks were different in size, capacity, performance. Those were located in different countries, as you know, because internet is global. So that's why this caused the fragmentation of the network itself. So internet is a network of thousands of other networks, which are very different, and that's why it is fragmented in its essence, which determine the product, the current internet routing protocol design. And that protocol is Border Gateway Protocol, created in 1994. So this protocol is still used today, and it's very, very old. It's very non-dynamic, non-programmable protocol. Companies are struggling because this protocol causes a lot of internet instabilities and security problems, which cost enterprises huge sums of money every year, and also this and then regular people also are touched by this because internet service providers are just not capable of providing any good service, because these problems so embedded deep into the internet that we need a new design, basically.
So when would we as consumers see this most? Would it be when we're loading large amounts of data from far away, or is this something that the average person would only see intermittently?
I think a lot of people see their internet connection getting bad, and stop working, or for example, especially gamers are usually not satisfied by the quality because you have to connect into different servers around the world, and this is where all the problems starts to come up. Also, live streaming, people who watch a lot of live streaming, the quality of live streaming, we all know that to do a good quality live streaming is not an easy task sometimes. So those, like, internet basically like kills our nerves sometimes for regular people, but it causes like huge pain for companies worldwide, which operate on public internet and which are vulnerable to attacks, to BGP attacks, for example. Very like nobody can control BGP attacks right now. I think it's a huge problem, especially also for the blockchain industry and those kind of things, So yeah, so I think everyone feels it, and especially technology companies feels it. Users feel it because they are the consumers of the content. So I think moving forward, if we're talking about VR, VR gaming, if we are talking about VR conferencing, um, things like things like AR stuff at your home, those kind of things, those will require a new internet design because this one is not scalable and not it's just probably not possible.
But I imagine you're
provide
not going
right
out
now.
and laying down new fiber optic cables or ripping up old copper. Or maybe you are, I don't know. But how do you redesign the internet without redesigning the physical infrastructure?
Yeah, physical infrastructure. That's a very good question. So right now, that's why we focused on segment routing protocol. This protocol was created by Internet Engineering Task Force, which is the main internet governing international body, in the end of 2014. So it's a very new protocol. It was created to use some of IPv6 features and this enable, because what IPv6 basically added a custom fields in a data packet. So if you have a data packet, because data packet is the smallest unit you can send over internet, yeah. So a data packet usually uh, is a source, a destination, and data itself. So IPv6 added a custom field where you can type something you want into a packet itself. And a segment routing then is a protocol which enables routers. It could be commercial routers sitting in a data center. It could be a home router. It doesn't matter. It enables routers, simple routers, to understand what's written in those headers, understand what's written in the packets itself. So once a router can read it and you can program something in this header, then you can program the packets and essentially data becomes smart, because data then has all the information related to how to route that data across the internet. So then routers can speak the same language because they all understand the same protocol, and they can read the headers and this is how the network is being programmed. So segment routing IPv6 basically, because and the adoption of IPv6 is increasing, and it's just a matter of time when the whole internet become IPv6. And the segment routing is adopted by companies like Cisco, Barefoot, one of the biggest router producers. Cisco is the biggest one. Then also Juniper recently. So it says that the major companies are starting to support the openness because it's an open protocol. Yeah, the corporates understand that the only way to innovate is to use a standardized protocol, acceptable and open to everyone. And then if you have this protocol, you can unify the infrastructure because it starts speaking the same language. And once you get it there, then you can introduce blockchain, which will act as a distributed database, basically. Because right now, for internet routing to evolve, you need to have a database, because without a database, it's impossible to program anything. So we are focusing NOIA. We are focusing on providing this database.
So, as I understand it, the internet right now is made up of a spaghetti soup of connections between many smaller networks. These smaller networks will talk to each other, but it's not 100% efficient which route the data will take.
Yeah.
So if I want to send data to you, or if we want to do a live stream, then it might take an inefficient route and our internet connection will be randomly slow, or data packets will drop and we will be frustrated. And for companies, this means a lot of money. And so what the solution is to change the way data is transferred by adding a programmable layer to the data, and then getting the companies that make routers to recognize that programmable data, so that you can, instead of taking sort of the stupid route, which may be not efficient, you can program it to take the most efficient route all the time. Automatically. Okay, that makes sense.
Yeah.
Now, the blockchain, I'm still not 100% sure why we need the blockchain in order to facilitate that.
So it happens that in order to create programmable internet, you need to provide an incentive for someone who has a router to open up the router. In order to incentivize that, you need to provide a financial benefit. Sell it,
so
basically.
if I've got one of these more modern routers that can handle IP version 6, I still have to turn on segment routing. That will cost me money, and so you have to give me a reward for doing so.
No, that won't cost you money. That will be for free. You just open.
But
up.
I still need an incentive to do it, and so
participate.
by doing it, then suddenly I have a positive incentive. I'm getting rewarded for participating in and rolling over into this new generation of internet, and suddenly everybody is happier.
Yeah, I think that so you can participate yourself. You can also, while you participate. Right now, we want to connect people not only to participate and to contribute resources, but to use the programmable internet at the same time while participating in the network. So that's a very strong message, because you, as an internet user, you can start sharing your internet, and then you can but both you can use the programmable internet and get the best connection possible on public internet.
I'm curious about the token economics. If you've got a token and you're rewarding people for providing their hardware, people provide hardware and they turn on the segment routing so that they can use your system, and they get rewarded with tokens. That withdraws value from the system. How does value go into your system?
So first of all, people who would like to use programmable internet, they have to pay with the digital currency. Yeah. So this is how the value is being created. And but if you run a node, and so you can get rewarded if someone else using your bandwidth. But you can also, but if you earn a token, you still spend the same token or some amount of those tokens to use the programmable internet. So basically, it's like sharing the internet and sharing the resources of the tokens itself between the participants of the network. If there are new people who would like to join the programmable internet, they can buy tokens and then start participating. So this is how the economy works. And the next week we're announcing the tokenomics paper. And also this is not all, because digital currency, NOIA digital currency, is used not only for as a medium of exchange in this case, but also as a transaction fee on the distributed ledger. So every transaction has an associated fee. NOIA tokens is being used to pay that fee. And this fee goes to inflationary pool model, and another percentage goes to a masternode reward pool. So those things, those details will be announced. Those are right now on our website, some of them, but a detailed paper written by Bill Norton will be announced.
We were talking a little before we started recording today, and you mentioned that Bill Norton had joined you, and that was a big deal. Why don't you tell us a little bit about that?
That's a very big deal for us as a startup, because Bill Norton served as a co-founder of Equinix, which is the largest data center operator in the world. worth for $40 billion right now. So, and Bill been working in internet industry all his life, starting from associations like big international organizations, to working with companies like NVIDIA, LinkedIn, other big companies in the internet field. So he even written a book about the internet business, which is one of the most popular books on this topic. So Bill joining the team and helping us to co-found the concept of programmable internet really changes, I think, the game completely, because right now we have the best people possible.
How did you convince him to come on board?
People like Bill Norton, they are passionate about the internet, and they've been working in this space for all their lives.
What's coming up? What can we expect coming from NOIA Network in the future?
So so right now we've been running our testnet for about a year, and we have more than 5,000 nodes globally, sharing the internet connection. So currently right now we're launching our token on KuCoin on the 22nd of July. So after the launch, we'll be working on starting the network and starting releasing a final version of the application.
Dom, I wish you all the best. Thank you very much for coming on the show, and I hope to have better download speeds in the future thanks to you.
Okay, thank you, Nathan.